Hello and welcome again to our continuous series of mathematics lessons. We have been looking at the topic algebraic expressions, equations and inequalities. In our last lesson, we looked at how we can be able to solve simultaneous linear equations by use of two methods. That was substitution and elimination. If we can be able to review one of these two methods very fast, if you are given a question 2x plus y is equals to 5 and another equation 5x plus y is equals to 11, we can be able to use substitution to solve this particular question. We say that the first step is writing one of the polynomial in terms of the other. If this is our equation 1 and that is equation 2, we can develop another equation 3 that will consist one of the polynomial on one side and the other polynomial on the right hand side. In this particular case, we can decide to make y the subject of the formula, so that we'll have y is equals to 11 subtract 5x as our equation 3. Then we substitute the value of y in equation 3 to the value of y in equation 1. That will give us 2x plus, instead of writing y, we put the 11 minus 5x is equals to 5. When we solve this, 2x subtract 5x, which are like terms, you'll get negative 3x plus 11 will go to the other side, so is equals to 11 is equals to 5. 5 less 11, this will be 3x is equals to 11 from 5 will give us negative 6. When you want to get the value of x, you divide both sides by 3, negative 3, and this will leave us with x is equals to 2. After getting the value of the first polynomial, you proceed and replace that particular polynomial on the equation containing the other polynomial. So for you to get the value of y, we need to substitute the value of x in our equation 3, and therefore y will be given by 11 subtract 5x, but you already know that x is 2, so that will be 5 multiplied by 2. So this will be y is equals to 5 multiplied by 2 is 10. When subtracted from 11, you will get 1, and therefore the solution to that question is x is equals to 2 and y is equals to 1. Now that is the substitution method. What if you are supposed to use elimination method? Using the same pair of simultaneous linear equations, we can use elimination to solve the value or to get the value of x and y that satisfies these two linear inequalities. We say that in elimination, we tend to eliminate a pronumeral so that we remain with only one pronumeral. And it is always good to inspect where we have pronumerals consisting or containing same or equivalent coefficients. Like in this case, if you look at the pronumeral x, the coefficient of x in the first equation is 2. It's 5 in the second equation, so they are not the same. And here, the coefficient of y is 1, the coefficient of y is 1. Therefore, it is easier for us to eliminate y in this particular case. Now, for us to be able to eliminate this y, because the sign is positive, then we are going to subtract equation 2 from equation 1. When you subtract, 2x subtract 5x is negative 3x. y subtract y, you will get 0. Then 5 subtract 11, you will get -6. This is our equation 3. If you solve this equation 3, it will give you the value of x to be 2. Then you can now go back and replace in either equation 1 or 2 to get the value of y. We can replace this 2 in either equation 1 or 2. Let's replace it in equation 1 to find the value of y. That was 2x plus y is equals to 5, but x we have been told is 2, or we have found out x to be 2. So when you make that replacement, this will give us 4 plus y is equals to 5. When you collect the like terms, you'll find that y is equals to 5 minus 4, and hence y is equals to 1. So the two methods are applicable whenever you are solving simultaneous linear equations. We now want to move on and look at how we can be able to apply these two methods in solving different mathematical problems. So there are certain procedures that are normally followed whenever you want to use either of the two methods to solve a simultaneous linear equation. The first method procedure, after reading that particular statement or the word problem, you need to define or set pronumerals that are going to represent some statements in that particular question or problem. So you define two pronumerals, and these are the unknown terms that you are going to use by writing down what they represent. Like if you're talking about the cost of maybe beans and maize, you can let C to represent the cost of maize. You can let C to represent the cost of beans. That's what you're talking about, defining or setting up two pronumerals. Number 2, write a pair of simultaneous equations from the given information. Now from that particular information, set or come up with a pair of simultaneous equations which you can now proceed into step 4 of step 3 of solving them. Solve the equation simultaneously by either substitution or elimination. So the two methods are applicable. Then step number 4, it is always important you check whether that solution actually satisfies the two equations. So check that the solution satisfies the problem therein stated. And then of course number 5, or the last step, write a statement or give a statement of your answer. In that case, we say you express the answer in words. So these are the 5 critical steps that are normally followed whenever you want to solve mathematical problems simultaneously. So we have said that in the first case, you define two pronumerals by writing down what they are going to represent. Then you come up with a pair of equations which you are going to solve by either use of substitution or elimination. Then after solving, check if your answer satisfies that pair of equation, and then finally you express it in terms or in words. Andrew bought 2 containers of ice cream and 3 bottles of maple syrup for a total of $22. At the same shop, Betna bought 1 container of ice cream and 2 bottles of maple syrup for a total of $13. How much does each container of ice cream and each bottle of maple syrup cost? Now this is a mathematical problem or a statement which involves the cost of 2 items. We have ice cream and we also have maple syrup. We have been told that Andrew went and bought 2 containers of ice cream and 3 bottles of maple syrup. Within the same shop, we have another person, Betna, who bought 1 container of ice cream and 2 bottles of the maple syrup at a total cost of $13. The fact that these people purchased the items from the same shop is that the cost of 1 container of ice cream and the cost of 1 bottle of maple syrup is the same. Now, using our procedures in giving a solution to this particular question, we say that in step 1, we come up with 2 pronumerals that are going to represent some particular items in this particular statement. Now, in this case, we have the cost of ice cream and the cost of a bottle of maple syrup. So we can let our pronumerals be x and y, so that x represent cost of 1 container of ice cream and y represent cost of 1 bottle of maple syrup. So that is statement or step number 1. Step number 2, we need to come up with a pair of simultaneous equations to represent this particular problem or statement. We have been told that Andrew bought 2 containers of ice cream. That means the total cost for ice cream that Andrew spent was 2 multiplied by the cost of each container of ice cream, which is X, plus he also bought 3 bottles of maple syrup, and I've been told that the cost of 1 bottle of maple syrup is Y. So if he bought 3 bottles, that means he spent 3Y. Now the total amount of money that is spent in that shop was a total of $22. So this one will be our first equation. Our second equation is from Bettner. He bought 1 container of ice cream, therefore he spent X dollars, plus he bought 2 bottles of maple syrup, therefore he spent 2Y dollars. Now when he summed up the total amount he had spent in that particular shop, he found it to be $13. So this one will give us a total of $13, and this forms up our equation 2. Now this is the second step. We have come up with the pair of the simultaneous equations. We need now to go to step 3, that is solving them by use of either elimination method or substitution method. Either of the method works. So let us use substitution method. With substitution, it is easier for us to work with equation 2 so that we express x in terms of y. Now in this case, x will be equal to 13 subtract 2y, and this will be our new equation, equation 3. We now want to substitute the value of x in equation 3 to the value of x in equation 1. So that where there is x in equation 1, we put 13 subtract 2y. So when you substitute, you'll get 2 multiplied by x, which is 13, subtract 2y, plus 3y. This one will still give us 22. When we open up this bracket, 2 multiplied by 13 is 26. Subtract 2 multiplied by 2y, you'll get 4y, plus 3y is equals to 22. When we group the like terms together, we'll remain with minus 4y and 3y on the left hand side. And when you add negative 4y and 3y, you'll get negative y is equals to 22 less 26. So this will tell us that negative y is equals to negative 4. And therefore, the value of y can be obtained by dividing through by negative 1, which will give us 4. After getting the value of the first pronumeral, which is y, we now want to get the value of x. And it is easier if we use the third equation for us to get the cost of 1 container of ice cream, which is x. We had been told that x is equals to 13, subtract 2y. Subtract 2y, and therefore x is going to be 13, subtract 2y. Y we have been told is 4. So 2 multiplied by 4, you will get 8. Therefore, x will be equivalent 13 minus 8, you'll get 5. Therefore, you can be able to say that the cost of 1 container of ice cream, which is x, is $5, while the cost of 1 bottle of maple syrup is $4. Maple maple syrup. Step 4 or step 5 is also very important. That is checking whether 4 and 5 are going to satisfy our given equation or the equation that you had formed. We can just check very fast if it satisfies the first equation. Now we've been told that x is 5 and y is 4. So when you replace 2 multiplied by 5, you'll get 10. 3 multiplied by 4, you'll get 12. When you add 10 and 12, you'll get 22. So that is okay. You can also cross-check using the second equation that the two solution satisfies the second equation. We have been told that x is 5 and y is 4. So that will give us 8. When you add 5 and 8, you'll get 13. So it satisfies. And you'll have checked or you'll have confirmed that indeed 5 and 4 satisfies the pair of equation that you had come up with. Steve bought 5 cricket balls and 14 tennis balls. For $130. Ben also bought 8 cricket balls and 9 tennis balls for $141. Find the cost of each cricket ball and each tennis ball. Solution. So the first step is coming up with 2 pronumerals to represent the cost of 1 cricket ball and 1 tennis ball, because that is what the question wants. We can let x be cost of 1 cricket ball and y be the cost of 1 tennis ball. You can always use any pronumeral that you wish to use. The second step, we come up with a pair of simultaneous equations to represent this particular problem or statement. You have been told that Steve bought 5 cricket balls. That means he spent $5 plus he also bought 14 tennis ball, and each tennis ball is $y. So he'll spend $14. The total cost that Steve will spend or use is $130. So this is our first equation. Ben also bought 8 cricket balls, so he spent a total of 8x plus he also bought 9 tennis balls. That means he spent a total of 9y. A total expenditure for Ben added up to $141, and this is our equation 2. Step 3 is solving this particular pair of simultaneous equations by use of either elimination or substitution method. In our past example, we used substitution. Let us now use elimination in solving this particular problem. We have 5x plus 14y is equals to 130. 8x plus 9y is equals to 141. Now, because in this particular case there are no term, or each pronumeral consists of different values before them, that is different coefficients. Therefore, we need to make either x or y to have same coefficients, and to do that we are going to multiply the numerator by 8 and we multiply the denominator by 5. So we multiply this by 8, the first equation by 8, we multiply this equation by 5. When you do that, 8 multiplied by 5x, you'll get 40x plus 14 multiplied by 8, it will give us 112y, which is equals to 130 multiplied by 8, which will give us 1040. In the second equation, we are multiplying all through by 5. So 5 multiplied by 8, we are going to get 40x plus 5 multiplied by 9, you will get 45y, and 141 multiplied by 5, you will get 705. Now, in this case, we have achieved in making sure that one of the pronumeral have got same coefficient, that is 40 and 40, and therefore we can now be able to proceed. If these are equation 3 and this is equation 4, we can now go ahead and subtract equation 4 from equation 3. When we do that, you'll get that this is 0, and therefore we'll have eliminated x as a pronumeral from that particular pair of simultaneous equation. Then 112 subtract 45, you'll get 67y is equals to 140 subtract 705, you'll get 335. That can be our equation 5. And therefore, you to get the value of y, we need to divide both sides by the coefficient of y, which is 67. When you do that, you'll get that y will be equal to $5. That is the cost of one tennis ball. We need to substitute this value of y in either equation 1 or 2 for us to get the value of x. Let us replace it in the first equation. So this will be 5x plus 14y, but y is 5, so we take 14 and multiply it by 5, should give us 130. So this will be 5x is equals to 130 subtract 14 multiplied by 5, which is 70. Therefore, 5x will be equal to 60. And therefore, for us to get the value of x, we need to divide both sides by 5. And this will give us that x is equals to $12. So the cost of one cricket ball is $12. $12, and then one tennis ball is equals to y, which is $5. The fifth step we said is very important. Always cross-check that the pair of solutions that you have can be able to satisfy the two linear equations that you had formed. Example 3. The entry fee for a fund run is $10 for adults and $3 for children. A total of $3,360 was collected from a total of 420 competitors. Find the number of adults and the number of children running. This is another mathematical problem that has been expressed in a statement. In coming up with a solution, in finding the total number of adult competitors and number of children competitors, we need to follow the steps that we had highlighted. So step number 1, we need to set two pronumerals. One will represent the number of adults, the other one will represent the number of children. So we can let x be the number of adults and y be the number of children. The second procedure or step, we come up with linear simultaneous equations to represent that particular information. You have been told that in this particular fund run, the entry fee is $10 for adults and $3 for children. So that means and a total of $3,360 was collected from the 420 competitors. These 420 competitors represents the total number of adults and children. And therefore, when you take x and you find the sum of x and y, it must give you 420, and that will be our first equation. X plus y, which are the number of adults and children, is equals to 420. Now you have been told that the cost entry fee is 10 for adults and 3 for children, and a total of that was collected. So in this case, there were x adults, so $10 was collected from adults plus y children. Each child was paying $3, therefore there was a total of $3 collected from the children, and this summed up to a total of $3,360. This is equation 1, and that is equation 2. We can now proceed and solve this by either use of substitution or elimination. Let us use substitution method in this case. And we want to to use equation 1 to write x in terms of y. So from 1 or from equation 1, x will be equal to 420 subtract y. We need to substitute, this is equation 3 now. We need to substitute this equation 3 in equation 2. So substituting value of x in equation 3 to value of x in equation 2, we are going to obtain 10x. So that means we take 10 multiplied by the value of x, which is 420 minus y, plus 3y should give us 3,360. When we open these brackets or we expand, we are going to get 4,200 subtract 10y plus 3y is equals to 3,360. When we group the like terms together, that means we must take 4,200 to the right hand side. And for us to do that, we must subtract it from both sides. So this will leave us with minus 10y plus 3y is equals to 3,360 less 4,200. When you take minus 10y plus 3y, you'll get negative 7y, which is equivalent to 3,360 less 4,200. You'll get negative 840. And therefore, you to get the value of y, we need to divide both sides by negative 7, which will give us 120. So that means which will give us 120. So this means that in that particular competition, y represented a total of 120, and y was representing the number of children. So that means that in that particular competition, children were 120. We can therefore proceed and get the value of x by making a substitution of y in either of the two equations. Easier, let us use this equation 3 to get the amount or the number of adults, which was x. Now we were told that x is 420 less the number of children, which we have found it to be 120. Therefore, x using equation 3 will be 420 subtract 120, which will give us 300. Therefore, adults are 300 and children are 120. When you get the sum of that two, you'll discover that it will give you 420. Now this brings us to the end on the discussion of linear equations and also linear inequalities, plus the simultaneous linear equations and how we can be able to solve them using substitution and elimination. We now want to consider another set of expressions and equations which the power of x or the power of the given polynomial is not 1. Of the form ax squared is equals to c. Now this is a quadratic equation of this particular form, ax raised to 2 is equals to c, where a, c are given terms or constants, and then x is a variable. So if you can be able to check this x, it has been raised to 2, or it has its power is 2, or the maximum power is 2. So any equation that consists of a polynomial with a power of 2, that becomes a quadratic equation, the word quadratic. So you can say that a linear equation with the highest power of the polynomial as 2 is referred to as a quadratic equation. We are saying it is in this particular form, so that if you have something like x squared is equals to 9, for example, we can be able to say that this is a quadratic equation because the highest power of the polynomial is 2. We are going to look at how we can be able to solve such problems involving quadratic equations. Now, for us to be able to solve such kind of a quadratic equation, we need to find the square root of both sides. That means you find the square root of the left-hand side, you find the square root of the right-hand side. And when you do that, you'll find that the square root of x squared is x, which will be equivalent to the square root of 9 is 3. But there's an important aspect here. What if we took negative 3 multiplied by negative 3? By the virtue of this one being negative, it will give us a positive at the end of the day, which will be 9. This one tells us that the answer or the solution to such quadratic problems is not only a positive digit. We can also have negative numbers. So like in this case, the answer can be either positive 3 or negative 3, which is normally simply put as either plus or minus 3. What about the case where this c will be less than 0? So when c is less than 0, that means it's a negative integer. And therefore, if it's a negative integer, then when you try to find the square root of a negative integer, let's say negative 9, then there's a problem. In this particular case, when c is less than 0, that means it's a negative number, then it does not have a square root, because, or in other terms, we refer to that kind of a solution as only imaginary. And therefore, that particular question or problem will not have a solution. Let us consider an example. Find all possible solutions to the following equations. A, x squared is equals to 25. B, 2x squared is equals to 18. And C, a fifth x squared is equals to minus 20. We want to solve each of these to obtain the value of x. So we have said for us to get or to solve this particular quadratic equation, we need to find the square root of both sides. So this one will give us that x will be equal to the square root of 25, which is either plus or minus 5. And therefore, the two possible answers to this question is that x is either 5 or minus 5. With this second equation, we first need to ensure that the coefficient of x squared is 1. Therefore, we need to divide both sides by 2, which will leave us with x squared is equals to 9. Now, for us to get the value of x, we need to find the square root of both sides. When you do that, you'll find x is equals to the square root of 9, which is again either a plus or minus 3. Therefore, you can be able to say that this second equation has its solution as either plus or minus 3. Lastly, for us to be able to solve part C of our question, we need to multiply through by 5 to eliminate this denominator. When you multiply through by 5, you'll get that x squared is equals to negative 100. Now, for us to get the value of x, we need to get the square root of both sides. Get the square root of x squared, the square root of negative 100. This will give us x is equals to. Now, we have said that this c is less than 0. And whenever c is less than 0, that is it's a negative number, then that particular equation is not going to have solution. So in this particular case, it will be an imaginary number which is non-existent, and therefore this particular part has no real solution. So this brings us to the end of the whole topic, algebraic expressions and equations and inequalities, where we have looked at several aspects of this particular topic. We said in algebraic expressions we use pronumerals to define a given statement. In equations, we introduced the use of the equal sign, the right-hand side and the left-hand side in an equation. Then in inequalities, we said we normally make use of the inequality symbols, which are 4 in number, either greater than, less than, greater than or equals to, or less than or equals to. Thank you and welcome again.